the Copernican revolution. The next stage was that reached by Copernicus. Copernicus was a very strange character and person. Indeed, he was born in Poland, which had just partially thrown off the hold of the Teutonic Knights. His uncle was a bishop who, according to history, gave him a very long and thorough education in Italy. He studied law and medicine, philosophy, and incidentally picked up a certain amount of astronomy. He was very interested, as people rarely were at the time, in navigation, but he was one of these very dry water sailors, for though he lived most of his life within 20 miles of the sea, he never went down to it. Nevertheless, he did write a great deal about navigation. Of course, he looked into the whole system of Ptolemy, of which many criticisms were to be found, as were criticisms of Columbus as well. Of Columbus, it was pointed out that he should not have done it, that he did not really know enough, that he was a very bad navigator, that his ideas were quite wrong, and he just happened to have the good luck to get where he did. Of course, the same is largely true of Copernicus's ideas on navigation as well, nor was Copernicus a terribly bright astronomer. He did not make accurate observations, for we have a few of his observations, and they are mostly wrong, and his tables are not particularly good, but Copernicus had an idea, of course, which was very characteristic of a Renaissance revolutionary thinker. It was that the old system of the heavens was really a mess. One had only to try and read Ptolemy and consider all those eccentrics and epicycles to realize that nature could not make such a mess as that. It must have been men's thinking that had made such a mistake or muddle. He wanted to straighten it out. For example, we look at the universe as illustrated by Copernicus in De Revolutionibus Orbium Coelestium in 1543. We have the sphere of the fixed stars, the orbit of Saturn, the orbit of Jupiter, the orbit of Mars, the orbit of the Earth and Moon, the orbit of Venus, and the orbit of Mercury, and the Sun is in the center. And so we have all these circles looking like a target board, as if one was playing darts. However, this figure illustrates from Copernicus's book something that we know now. The circles were added as an extra, but everyone liked circles then. Of course, ellipses were not to be admitted until the next stage. Of course, the sun is plainly there in the middle, with Mercury, Venus, the Earth with the moon around it, Mars, Jupiter, and the fixed stars as the new immobile sphere. And you must remember that the old sphere was supposed to get around that enormous distance every 24 hours, and a lot of celestial mechanism was required for that. Of course, this sphere was easy. You only had to move a few planets about. Of course, this was what Copernicus himself had to say about that. He said that, quote, "Our ancestors assumed a large number of celestial spheres, for this reason especially to explain the apparent motion of the planets by the principle of regularity, for they thought it altogether absurd that a heavenly body, which is a perfect sphere, should not always move uniformly. They thought by connecting and combining regular motions in various ways, they could make any body move to any position," and then talk about the planets. Of course, you note that this is a purely mathematical question, what is called saving the appearances. Of course, it therefore seemed better, he said, to employ eccentrics and epicycles, a system most scholars finally accepted. Yet the planetary theory of Ptolemy and most other astronomers, although consistent with the numerical data, seemed likewise to present no small difficulty, for these theories were not adequate unless certain equants were also conceived. It then appeared that a planet moved with uniform velocity neither on its deferent nor about the center of its epicycle. Hence, a system of the sort seemed neither sufficiently absolute nor sufficiently pleasing to the mind. And having become aware of these defects, I often considered whether there would perhaps be found a more reasonable arrangement of circles for which every apparent inequality could be derived, and in which everything would move uniformly about its proper center, as the rule of absolute motion requires. After I had addressed myself to this very difficult and almost insoluble problem, the suggestion at length came to me how it could be solved with fewer and much simpler constructions than were formerly used, if some assumptions, which are called axioms, were granted to me. They follow in this order. Of course, again, the problem is that, of course, because of the defects, he considered whether there could perhaps be found a more reasonable arrangement of circles for which every apparent inequality could be derived, and in which everything could move uniformly about its proper center, as the rule of absolute motion requires. He says that there is no one center of all the celestial circles. The center of the earth is not the center of the universe, but only of gravity and of the lunar sphere. All the spheres revolve around the sun as their midpoint, and therefore the sun is the center of the universe. And lastly, that the ratio of the earth's distance from the sun to the height of the firmament, or that is the zone of the fixed star, that being the sun, is so much smaller than the ratio of the earth's radius to its distance from the sun, that the distance from the earth to the sun is imperceptible in comparison with the height of the star itself. Of course, this turns out to be a very vital point in theological and, of course, philosophical thinking, because it makes the universe very much bigger. There is nothing absolutely new in this in another sense, because, as I have said earlier, a similar statement to you before, not from Copernicus, but from Archimedes, referring to Aristarchus. But Archimedes had now been translated, and a scholar like Copernicus had read the passage which we considered earlier about the size of the universe. Further, he states that the earth has three motions. First, it revolves annually in a great circle around the sun. Second, it revolves on its axis. The third motion is due to the variation in the inclination of the earth's axis to the line joining the sun and the earth. On account of the distance of the sun from the center of the circle, the apparent motion of the sun is not uniform. And so to explain this lack of uniformity was one of the greatest problems, and I wish I had space to deal with it in more detail. However, most people do not worry about it, but astronomers had to worry about it. Of course, how is it that the summer is not the same length as the winter, that the equinoxes do not occur halfway through the year, that they are not halfway between the solstices? The explanation was that the earth, as we would say now in our modern times, or the sun, as they said then, moved slower at one part of the year than another. Of course, there had to be a lot of fiddling, so to speak, to get that to come out right. This was the fiddling which Kepler did, Johannes Kepler. But the really vital explanation was given as above by Copernicus, and was another justification for his describing the planetary orbs as follows. Quote, "In the middle of all sits sun enthroned. In this most beautiful temple could we place this luminary in any better position from which he can illuminate the whole at once. He is rightly called the lamp, the mind, the ruler of the universe. Hermes names him the visible god. Sophocles' Electra calls him the all-seeing. So the sun sits upon a royal throne, ruling his children, the planets, which circle around him. The earth has the moon at her service, as Aristotle says in his De Annabilis. The moon has the closest relationship with the earth. Meanwhile, the earth conceives by the sun and becomes pregnant with an annual rebirth." End quote. Now, this is the real stuff. I mean, it is magic, it is analogy, and yet it happens to be true. But you can see that the reasons which give rise to an idea are not necessarily the same reasons as will prove that the idea is correct. Copernicus wrote all of this down in his On the Revolutions of the Celestial Orbs, usually referred to as De Revolutionibus. I referred to you to the philosophy of science and history of science if you want to read more about the history of scientific authors and their the philosophy of science itself. The orbs were the same, of course. He still thought of the planets as being fixed on the surfaces of a set of hollow crystals, but he had made a piece of celestial clockwork, which was much simpler. It was also much bigger, and that was to cause trouble later on. Of course, he himself succeeded in this enterprise remarkably well. He wrote the book, he presented it to the Pope, and the Pope approved of it, and it was circulated among discerning people and printed. It is true that this was already at the time when heretics were around, and it was printed by a Protestant printer, but of course it was not disapproved of by the Pope, and it stayed perfectly respectable, right down to the year 1615. That is, for nearly 100 years, before anyone really said that there was anything seriously wrong with it. And so you see, one might first of all arrive at a new answer, but when then reasons have to be found for the answer, then the criticisms, which were many, had to be overcome. And that will be the subject of the next discourse. We will speak about Tycho Brahe, and Johann Kepler.